Those of us in the environmental field, especially the nonprofit sector, are always trying to do more with less. Plant more trees, restore more wetlands, conserve more habitat. But it's a challenge to know where to work when there is literally a world of opportunity in front of us. Over the last 50 years, with the advent of satellites and GIS, new technologies have provided increasingly advanced ways to model the environment. These tools are continuing to provide us with an unprecedented understanding of how the natural world works. As our knowledge of the landscape has increased, new branches of science have emerged that do everything from tracking how water moves across the landscape, to identifying how much carbon forests are sequestering, to deciphering how land management decisions might impact historic viewsheds. But as with all models, they have limitations. They can do a great job at identifying general areas that are a priority, but they often lack the detail needed to evaluate the benefits of specific projects. There is a disconnect between the scale at which we are planning and the scale we were working. This led to a system where we measure success based on how much work we did, not how good that work was. Funding programs focused on finding the biggest projects, not the best ones. The thinking was that if we did enough, the averages would work out and we'd meet our environmental goals. Now, in some industries, quantity over quality is okay, but in our world, that isn't going to cut it. Not when our climate is about to cross an irreversible threshold and species collapse is creeping ever closer. We had to figure out a way to shift the system to incentivize performance, not just effort. So we looked to underutilized data sets and technologies like high-resolution imagery, LiDAR elevation data, and large-scale computing. These tools have been used for years in the academic and private sectors, but they've not made a significant jump to the nonprofit world. Access to these technologies are still out of reach for the vast majority of environmental organizations, where many partners are lucky to have a dedicated GIS analyst, let alone having a workstation capable of processing terabytes of imagery. But that is starting to change. We see how processing data in the cloud makes it feasible to grind through data analysis tasks that have prevented us from using high-resolution information to model entire landscapes. This unlocked the concept of precision conservation, getting the right practices at the right scale in the right places. And by shifting our models from a 30-meter to a 1-meter resolution, not only do we now have 900 times as much information to work with, we could see both the forest and the trees. We could tell our partners exactly where in the landscape to work with a higher degree of precision and accuracy. We're working with the academic community to transform research into practice and rethinking how we map hydrography. And we're not only creating a more accurate map of where water flows, we've transformed that information from stream center lines to a multidimensional product. Access to this information is leading to a renaissance of modeling, as traditional limitations are no longer an issue. In the Chesapeake Bay, one of the largest and longest running restoration efforts in the United States, these new data sets are the basis for all future modeling efforts. Scientists and practitioners alike are rethinking how they can clean up entire watersheds. We're seeing new strategies like restoring impaired streams based on a coordinated and strategic approach, and pay for performance models that reward high-performing projects, not just big ones. But it's not just about having better data. We need to share our understanding of how this new information can help solve real-world challenges. We need easy-to-use tools that make GIS accessible to conservation and restoration partners of all sizes if we want to make a difference. Luckily, as we've seen increases in the availability of better data, we've seen a similar jump in web and mobile-based geospatial solutions. Whether at your desktop, in a coffee shop, or standing in a farm field, we now have access to astounding data and analysis capabilities. We can work in real time, tweaking the footprint of a project to understand how small changes in design can have an outsized impact on performance. We can collect data in the field and immediately have it accessible across our organization. And most importantly, we can share our information. Breaking down the silos in which we all too often work allows us to access our collective knowledge and address big challenges. Let's face it, the issues we are tackling are larger than any one organization can handle, but creating a robust and coordinated approach allows everyone to pitch in. At the Center for Geospatial Solutions, we know what technology and collaboration can do, and we are focused on working with partners across the environmental sector to make sure they are asking the right questions, have the right data to answer them, and are building the partnerships they need to be successful. We need to get people to start thinking geospatially if we're going to tackle global challenges that are inherently spatial. We need to move beyond asking what questions can I solve using the information I have on hand to what is the appropriate data I need to answer the questions I have. I am confident that we are up to the challenge, but it's going to take a concerted effort to bring partners together and identify opportunities for collaboration that leverage all of our strengths. But if we do, I'm confident that amazing things are going to happen. Thank you.
Thank you so much for this opportunity. I'm so excited. But am I even qualified to be talking about this? What if they realize that I wasn't the person that they wanted for this talk? Oh, I should have put doctor. Is that a typo on the date? That's the inner monologue or my inner saboteur that's questioning me, that's wondering if I'm even supposed to be doing these things. They're going to ask, am I a fraud? It's called imposter syndrome. And you should know that everyone feels like an imposter sometimes. And I've been reading more about imposter syndrome, and I came across this book that talks about how capable people suffer from the imposter syndrome and how they thrive in spite of it. And it talks a lot about how society and our families shape who we are and how we perceive ourselves, who belongs in science, what does success look like, down to how we speak in front of the public. And it's skewed a lot towards minoritized groups. Now, I'm a Latina, a first generation Mexican American with both a master's and a PhD in geology. I'm one of the few. And when people find out that I have a PhD in geophysics, they seem really surprised. And it makes me wonder, am I an imposter? Do they think that I didn't deserve or I didn't earn my PhD? Do I belong here? But then I realize that that's my inner monologue and my inner saboteur. And everybody feels this way sometimes. And there are some ways to cope with imposter syndrome. Most of all, be kind to yourself. Write down your successes, reflect on all that you've accomplished, and know that you're not alone. It happens to the best of us. As a kid, I always wanted to study earthquakes, so I became a geologist, and I had to go out to the great outdoors. Go to the bathroom outside, sleep on the floor, be exposed to the elements. And it turns out I don't really like to be outside. I don't really do well in the heat. But it also turns out that you don't have to be a field geologist to study earthquakes, because there's a field called geophysics where you can sit in front of your computer and be indoors. Now, geophysics does require a lot of math. And while I don't consider myself to be good at doing arithmetic in my head, what I am good at is writing down notes and referencing them and asking a lot of questions, especially when I'm stuck. Now you'd think she went through all this school, she must know exactly where her career is going next. But that wasn't really the case. And I kept on wondering, am I gonna be making the wrong decision? But I decided to try something new. And I wondered, what would it be like to talk in front of people? So I became an educator at a science museum where I was an assistant to Galileo. And I was also an astronaut on the surface of Mars. I pretended to be something that I wasn't. And I was okay with that because I became an actor at a museum, which is called a performer. And now, as an educator at Ncar, I talk with people about the atmospheric sciences, which isn't what I studied. But even though I'm not an expert in this field, I feel comfortable enough to talk with people because I'm constantly learning from those scientists. And in this job, it also meant I had to go back outdoors. But this time it was different because I wasn't the scientist collecting the data. I was a person behind the camera interviewing scientists, then talking with kids and the general public about what those scientists were doing out in the field. And I've also led workshops for undergraduate students. But because I wasn't formally trained as a teacher, I wondered, did they make a mistake hiring me? But through the job, I learned how to be a mentor to support these students as they pursue their careers. One of my goals at Ncar is to increase bilingual science communication in the geosciences and to create a community of practice to engage with the Latinx and Hispanic communities. The goal is to let people know that they are welcome in this field and there are careers in this field. I'm also the co-founder of the Society of Latinx and Hispanics in the Earth and Space Sciences. And the goal is to build a community for these scientists so that they know that they're not alone and that they belong in these fields, and to show the world this is what a scientist looks like. Through my work and this presentation, I want you to know that you can be anything that you can imagine. Even though I didn't like the outdoors, I became a geologist. Even though I'm not a trained actor, I was a performer at a science museum. And even though I don't consider myself great at math, I was a geophysicist. And it's okay to be afraid of trying new things. In the last year, I've become imposter syndrome. I become a comedian. And I think in life, the biggest thing is to realize that it's okay to try new things, to figure out what you like and what you're good at, and to take chances, make mistakes, and get messy, like Miss Frizzle would say.